Good evening, all of you. So, in this session, we are going to discuss electrochemistry. Right. Okay. So let us start electrochemistry. So very important chapter. 2 questions will come from this chapter. Mostly you will get numericals. Right. So let us see what are those numericals. So let's start with galvanic cell. Okay. So what is galvanic cell? Galvanic cell. Let us see what is galvanic cell. So galvanic cell contains 2 half cells. How many half cells it will contain? 2 half cells. In which 1 half cell contains zinc rod placed in zinc sulfate solution. So here you will have and copper rod placed in copper sulfate solution. This is copper rod, right? These 2 are connected externally by an ammeter. These 2 are connected internally through salt bridge. So this is a salt bridge. Okay. Now this is a zinc rod which acts as anode. This is a cathode, that is copper. This is zinc sulfate solution. And this is a copper sulfate solution. Now what happens? What happens here? So this is a key point here. Now zinc rod dissolves in zinc sulfate solution. That means what happens at anode? At anode, this zinc rod dissolves in zinc sulfate. That means zinc is converted into Zn+2 by releasing 2 electrons. Now these electrons will flow into the copper sulfate solution. What is copper sulfate? Where it is present at cathode. At cathode. At cathode, Cu+2 will accept those 2 electrons and convert it into Cu. So at anode, what will happen, sir? Oxidation. And cathode, reduction takes place. So this you can keep it as generalization, because always at anode oxidation takes place and always at cathode reduction takes place. Now let us write overall reaction. What is that overall reaction? Zinc, the Cu plus 2 reacts together to give Zn plus 2 as well as Cu, right? Then IUPAC representation. This entire galvanic cell is represented by zinc is converted into Zn plus 2. This is salt bridge. The double slasher line represents salt bridge. And Cu plus 2 is converted into Cu. Right? This is a galvanic cell. Next, electrolysis. During electrolysis, that means in this topic we have two important laws. Faraday's laws of electrolysis. So very frequently they are asking questions from this. In that first one, first law. So according to first law, what is first law of Faraday's law of electrolysis? First law of electrolysis. The amount of substance deposited is directly proportional to quantity of electricity passed through it. W is equal to electric current into time t in seconds. It's proportional. And proportional you remove, then you introduce ECT or IT. Both are same. C is current in amperes. Then here is electrochemical equivalent. Then C, current in amperes. T is time in seconds. T is time in seconds. Done. Then let us proceed for the derivation once again. Now W is equal to ECT. Now what is E there? Electrochemical equivalent. But E is equal to chemical equivalent by Faraday. So what is capital letter E? Chemical equivalent. That means E is equal to atomic mass by valency. That is N. Okay. So finally W becomes, what is E? E. ECT by NF. Sorry. E is represented, it is replaced with A. Atomic weight by valency, isn't it? So it becomes ACT by NF. Yeah, what? This first law of Faraday's laws. Next, second law. What is second law? Chemical equivalent. The mass of the substance deposited at electrodes is directly proportional to chemical equivalent. That means W1 by W2 is equal to T1 by T2. Okay, this is second law. Then next topic, conductance. So molar conductance directly I'm giving you formula, molar conductance formula. Specific conductance in 2000 by molarity, right? Then equivalent conductance. Again, specific conductance in 2000 by normality. Okay. This is about equivalent conductance. Then what is specific conductance? Specific conductance is represented by kappa. You will take specific conductance. It is represented by kappa. So kappa is equal to, okay, first we'll start with the resistance, then we'll proceed how we can determine kappa value. Right. Resistance, that is R. R is equal to rho into L by A. What is rho? Specific resistance. L is length of electrode. A is area of cross section. This L by A is called cell constant. Okay. Then what is specific conductance? Kappa, sir, based on this. So remember this, resistance is equal to rho into L by A. That I am considering again. Resistance is equal to rho into L by A. rho is equal to R into A by L. Okay. Then specific conductance kappa is equal to reciprocal of specific resistance 1 by rho 1 by RA by L. Or kappa is equal to finally 1 by R into L by A. So this is a specific conductance formula. Okay. Then next part. So I've seen what is conductance, specific conductance, and yeah, this is conductance. This is molar conductance. This is equivalent conductance. And finally, we have seen specific conductance also. Now, next point is about Kohlrausch law. It is used to determine conductance of weak electrolytes. How? Equivalent conductance of weak electrolytes. It is given by equivalent conductance of cation plus equivalent conductance of anion. That means ionic mobility of cation plus ionic mobility of anion. Let us suppose equivalent conductance of barium sulfate at infinite dilution is given by equivalent conductance lambda naught of cation plus lambda naught of anion. Let us consider an example. Equivalent conductance of CH3COOH. How you will get equivalent conductance of CH3COONA plus equivalent conductance of HCl minus equivalent conductance of NaCl. Now, how these are all strong electrolytes. These strong electrolytes dissociates into, this is CH3CO minus plus Na plus lambda naught of H plus lambda naught of Cl minus lambda naught of Na plus minus lambda naught of Cl minus plus minus. Then what is remaining? Lambda naught of CH3CO minus plus lambda naught of Na plus. If you combine these two, lambda naught of H plus. Now CH3CO minus and H plus will give you CH3COOH. It gives you CH3COOH. Did you understand? So this is about Kohlrausch law. Next. Nernst equation. So Nernst equation for metal electrodes. It is given by EMF of the cell is E0 minus plus 0.059 by N into log C. So here C is concentration of solution. N is number of electrons transfer. So for non-metal electrodes, non-metal electrodes, then EMF of the cell is equal to E naught minus 0.059 by N into log C. So this is for non-metal electrodes. It's for non-metal electrodes. Done, sir. Then is about Nernst equation. This is one more important part in electrochemistry. As I said, it is a very big chapter. I think in previous session we solved some questions, but it will be better if you have some basic idea about topics in this chapter. That is why I started these topics, so that you will get some clarity on these topics. Understood? So this is about Nernst equation. And finally, you will have batteries, types of batteries. Okay, how many batteries? Primary batteries, secondary batteries, like that. But that is completely theory part that you can study on your own. So as usual, let us try to solve some other questions also in this session. It's electrochemistry. Those 2 questions will come, so better you have to concentrate more on this. Done. So let us move to questions now. The first question today, the molar conductivity of a 0.5 moles per decimeter cube solution of silver nitrate KZNO3 with electrolytic conductivity of electrolytic conductivity of 5.76 into 10 power minus 3 at 298 kelvins. So this is the question. What we need to find out there, the molar conductivity. You have to find out molar conductivity. That means molar conductance. We just discussed that formula. Molar conductance is given by kappa into 1000 by molarity. Kappa into 1000 by molarity. So conductivity means specific conductance is given there. What is that? 5.76 into 10 power minus 3, isn't it? Then multiplied by 1000 divided by concentration. What is that concentration given? 0.5. So what is your final answer here? Now here you can see 5.76 into 10 power minus 3. 1000 can be written as 10 power plus 3 or 10 power 3. No need of sign here. 10 power 3. Then 0.5 as 1 by 2. So bring it 2 here. Means 2 into 5.76 into 10 power minus 3 plus 3. 10 power 0. Anything power 0. This is minus 3 plus 3. What you will get there? 0. So 10 power 0. Anything power 0 is 1. 1 into 5.6 into 2. So that is equal to what you will get. So 262, 2 7s 14, 1, 2 5 times 11.5. 11.52, but you're getting 11.52. So this is molar conductance of that solution. Done, sir. Next question. At 25 degrees Celsius, molar conductance of 0.1 molar aqueous solution of ammonium hydroxide is 9.54 ohm inverse centimeter square mole inverse, and at infinite dilution its molar conductance is 238 ohm inverse centimeter square mole inverse. Okay, then now the question, this is data given. Now the question is the degree of ionization. The degree of ionization of ammonium hydroxide NH4OH at same concentration and temperature is. This is the questions. We have to find out degree of ionization or degree of dissociation, right? So degree of dissociation or ionization, that is represented by alpha. So alpha is equal to conductance at known concentration. Next one, conductance at infinite dilution. Conductance at known concentration. So here 0.1 molar known concentration. This is the conductance, that is 9.54. Conductance at infinite dilution. This is the conductance, 238. So what you will get said, so find out that value. (9.54 by 238). What you will get said, 4.008%. Done, sir. This is second question. We still move to third question. following limiting molar conductivities. Limiting molar conductivities are given as, how they are given, lambda naught m H2SO4 x.
Yeah.
Now this is the question. Answer is x minus y plus 2z, x plus y minus z, x minus y plus z, last one, x minus y by 2 plus z. This is the given question. Now, by observing this, we can say that this is based on Kohlrausch law. Now, according to Kohlrausch law, so we are using Kohlrausch law here to solve this question. So we need to find out lambda naught m for CH3 COOH. So how we can get it? Here, if you consider H2SO4, consider H2SO4, how many are there? 2 hydrogens are there. 2 H plus ions and SO4 minus 2. So here, CS3 CO. Okay. Then let us see one by one. Let us write down here lambda naught m for CH3 COOH. Or you will get lambda naught CH3CO minus plus lambda naught of H plus. Similarly, lambda naught m for K2SO4. 2 into lambda naught K plus lambda naught of SO4 minus 2. Similarly, lambda naught for H2SO4. How it will dissociate 2H plus, that means 2 into lambda naught H plus ions plus lambda naught of SO4 minus 2, isn't it? And lambda naught for CH3COOK. Consider lambda naught CH3CO minus plus lambda naught K plus. These are the values given. Then how you will get a CH3 COOH? How you will get a CH3 COOH? So how we can get add equation, the first equation, which one? H2SO4, and multiply third with 2. So consider last one is third one. Let us consider so equation 1, equation 2, it says equation 3. What we need to do is add equation 1 and so is that equation so this is second equation. Add equation 2 and let me get back to those equations. Third equation. Equation third. We should multiply this third equation with 2 and subtract from, I think, equation 1 K2SO4 from 1. Now you do this. Equation add equation 1 and first 2 multiply with 3. What is, sorry, equation 3 is multiplied by 2. This equation. This is multiply with 2. What you will get then? 2 into lambda not CH3COOH. What you will get here? This multiply with 2. What you are getting? Two into lambda naught CH3CO minus and K plus. Let's add equation 2. What is equation 2? 2 lambda H plus ions plus 2, sorry, 2 not there. lambda SO4 minus 2. Okay. Now we added equation 2 and equation 3. Now subtract it from equation 1. What is equation 1? Equation 1. That is lambda naught K plus 2 into. Sorry, this is also minus lambda not SO4 minus 2. Then set. Now what you will cancel now here? Which terms are cancelled? Lambda naught SO4 minus 2 plus here plus minus 2 lambda naught K plus you do lambda naught. So finally what is remaining? 2 lambda naught CS3 CO minus plus 2 lambda naught H plus ions. Okay. Now here, this equation 2, that means lambda naught for H2SO4. What is that? X. What is that? X. So this is equal to X plus 2 into Z minus Y. Okay. So equation 3 is multiplied by 2. This equation is multiplied by 2. So that is why it is 2Z minus last one. What is that? Minus Y. Right. Then what you can make it common to 2 into lambda naught CS3 CO minus plus lambda naught H plus is equal to X plus 2Z minus Y is equal to lambda naught CS3 CO minus plus lambda naught H plus is equal to X plus 2Z minus Y divided by 2. What you will get? X minus Y divided by 2, 2Z by 2 plus J. This is your answer. Where is this option present? Fourth option is correct. Option D is correct. Done. Move to next question then. Numericals only we are dealing, sir. So this is a 5 ampere current is passed through a solution of zinc sulfate solution, sir. Zinc sulfate for 40 minutes. The amount of zinc deposited at the cathode is done, sir. And this is based on which law? This is based on first law of Faraday. So what we need, the amount of zinc deposited at the cathode. Okay. So amount of substance deposited is equal to ECT by F, or W is equal to ACT by NF. Now what is A? Atomic mass of zinc. What is atomic mass of zinc? 65.4 plus current in amperes. How many amperes of current? 5 amperes into time t in seconds. So 40 minutes are there into each minute contains 60 seconds. Okay, divided by n is number of moles of electrons transferred. Zinc sulfate means Zn plus 2. It's converted into Zn. So how many electrons are transferred? Plus 2 to 0. That means 2 electrons are transferred. So this is multiplied by 2 into Faraday's laws. Faraday's constant, that is 96,500 coulombs. Now, what you will get calculated, let me know, 65.4 into 5 into 4 into 6 divided by 2 into 965. What is that value you are getting there? It's direct formula, sir. Nothing, no twist in the question. Direct formula. Anybody got answer? We should get 4.065 grams. Done. So this is one more problem. Shall I move to one more question? Next question. So this is question number 4. Next, fifth question. The specific conductance of a 0.1 normal KCl solution at 23 degrees Celsius. 23 degrees Celsius is 0.012 ohm inverse centimeter inverse. The resistance of cell containing the solution at the same temperature was found to be 55 ohm. The cell constant will be so already we have seen what is cell constant. What is formula? L by A, isn't it? So what are given there? The specific conductance, that means kappa is given, that is 0.012. Okay, that is one point. Next, what else given? Resistance is given. What is that? 55 ohm. Then conductance. Is equal to 1 by R. That is 1 by 55. Therefore, what we need, sir? Cell constant. What is formula? N by A. L by A. If specific conductance is given, what is that formula? You've seen already the beginning of this discussion. Where is that? Yeah, here. If resistance is given, then rho into L by A. And rho into L by A. So when kappa is given, this is a 1 by R into L by A. When kappa is given, this is the formula 1 by R into L by A. What we need actually? L by A, that is cell constant. That is kappa into resistance. Kappa into resistance, right? So that is given. So what is kappa? What is that value given? 0.012. Resistance 55 5. So 0.012 into 55, that is 0.66 centimeter inverse. Done, sir. So this is about specific conductance of 0.1 normal KCl solution. Okay, so that's it for this session. So tomorrow, we'll start one more physical chemistry chapter. I think we completed solution, solid state, and electrochemistry as of now. Then let us see tomorrow chemical kinetics also. Okay, so after chemical kinetics, I'll move to organic chemistry, second period. Many topics to be covered. Okay, so tomorrow we'll meet with chemical kinetics. Chemical kinetics. Then we'll see organic chemistry, right? So anyhow, I'm sending notes, but also you just go through once again. Okay, so that's it for this night. Meet you tomorrow again. Good night, all of you.